This is multiple regression, example 1, Zagat's restaurant ratings. Zagat publishes restaurant ratings for various locations. Zagat data has been collected for overall rating and price per person at 50 restaurants in New York City and 50 restaurants on Long Island. We're going to develop a regression model to predict price per person based on overall rating and whether the restaurant is in New York City or on Long Island. That, of course, will be a dummy variable with x2 equals 0 for New York City, x2 equals 1 for Long Island. You may assume that the linear regression is an adequate model. Okay, let's make sure we're straight. We are predicting price per person. That is y. x1 will be rating. By the way, high rating is better than low. And x2 is the location variable, which is a dummy variable. Here are the questions we're going to answer. In particular, I'll give you a minute to read over these. All right, let's open up Excel and look at our data. As you can see, I've already got the columns correctly labeled. Let's think just a moment about units. Again, x1 rating is a numeric variable where a high number is better, no scaling of the data here. x2 location is strictly a dummy variable, 0 or 1. And look at the price. This is price per person. With no mention of units, that would be straight dollars. In other words, for restaurant number 1, the typical price would be a $50 meal. So now let's go to multiple regression. Data, data analysis, regression. Price again is our y variable. Two independent variables, and they are contiguous, so we'll highlight both x1 and x2. All right, we do have labels in the first row. We will put our output up here, tell it OK. All right, let me give you a moment just to glance at the screen. This is the typical regression from Excel. Now we're going to go into our 4 questions. The first question, what is the overall multiple regression equation? So let me give you a moment to look and find those numbers on here. This is the area, of course, where we get our multiple regression equation. Question 1, again, the overall multiple regression equation from Excel. All right, let's look at what that means. In fact, question 2 will do a little more detail, but let's look specifically at the intercept to begin with. In this problem, the intercept has no practical meaning because if you go back to the data set, none of the restaurants had a score anywhere near 0. The intercept has a practical meaning only if all the independent variables could legitimately be 0. That's not the case here. The slope of x1 is 0.96. That's saying that basically for every 1 point increase in rating, we would expect the price per person to be almost $1 more, 96 cents more. The 7.54 slope of x2 is telling us that if we're located at a restaurant on Long Island, we would expect the price per person to be lower, $7.54 lower for a restaurant with the same rating as in New York City proper. A little more specifically now, because that's what question 2 was asking. What is the slope of x1 and what is its meaning? The slope of x1, which we label b sub 1, is 0.96. Now let's answer what it means, particularly in terms of this problem. For each additional rating point, x1, the mean price per person by the way, which is y, is expected to increase $0.96, 96 cents or almost $1, holding location constant. Third question from our multiple regression was, what is the proportion of variation in price explained by rating and location? Let's pull Excel back up for a moment, let you look for that. Again, what proportion of variation in price, which is y, is explained by rating, x1, and location, x2? We're looking for r squared, in other words. Proportion of variation explained. I'll just write that shorthand. R squared y dot 1, 2, meaning we used x1 rating and x2 location, equals 0.59. Final question in example 1. What would be the average or mean price of a meal in New York City with a rating of 70? And you actually can still see at the top of the screen the regression equation. Mean price in New York City with a rating of 70. In other words, 70 is x1. That is our rating. And let me remind you that location, New York City in this case, is a dummy variable, and we set this problem up so that if a restaurant were in New York City, x2 equals 0. So looking at the equation at the top of the screen, let's just start with it. Now we've got it where we can see it. Let me scroll on down. Why don't we first of all get the equation for any restaurant in New York City. Then we'll come back and say specifically with a rating of 70. So for any restaurant in New York City, where x2 equals 0, again, any restaurant in New York City has a location, x2 equals 0. That term, of course, then drops out. So for any restaurant in New York City, here would be our regression equation. Now let's specifically calculate the average price for a restaurant in New York City with a rating of 70. I'll say y hat of 70. on average, we would expect the meal to be $53.50. If you're interested in doing an example to test the significance of the model, watch example 2 of this video series because it's going to be the same scenario.